Hello, and welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Jason Schwartz.
Thank you, Sherry, and thank you everyone for joining us today. I'm here to talk about green solutions for your vapor degreaser. And this is a part 3 of a 6-part series on vapor degreasing. So if you have interest, please check out the first 2 parts and stay tuned for parts 4, 5, and 6. I'll start with what is green. So when I started in this industry about 10 years ago, green was the key buzzword, referring to environmentally friendly solvents or chemicals. And I would say in the past 2 to 3 years, we've kind of transitioned away from just green to a concept of more sustainability. And as defined by Wikipedia, sustainability is a societal goal that relates to the ability of people to safely coexist on Earth over a long time. And while that sounds a little granola to me, I do like this concept because I think it does apply to manufacturing pretty well. Uh, you've got 3 pillars to sustainability, and that is the environmental, which we started about with the green, social, which is really talking about operators in this context. It's your people on the floor, and economic, because even if you have the latest, greatest solvent, if it costs you an arm and a leg, it's not feasible to work in your process. It's not sustainable. So, how do we make a vapor degreasing process or a vapor degreasing solvent sustainable? Well, we have to address each one of these pillars. So, we make it non-flammable and non-toxic. That means it's safe for your operators. You make sure that it's not a HAP, which is a hazardous air pollutant, a VOC, which is a volatile organic compound, or some other type of reportable substance where you're going to spend more time digging out how much you've used, how much you've brought into the plant, and that becomes an unsustainable operation. Lastly, it's got to be affordable, both on a price per pound basis, but also from your consumption rates. It has to have a reasonable amount of consumption, or else you're going to be spending more money even if it's a cheaper solvent. We also have to make sure that the solvent's distillable, because there's a lot of good distillation systems out there that will help you recover unused solvent. Your solvent stills can be usually around 30% oil. Now, that means you're throwing away 70% solvent. So making sure your solvent's distillable is really important, or else you're just going to be throwing away money. So what are your current vapor degreasing options? All right. The first option are the oldest generation solvents. These are your trichloroethylenes, MPB, perchloroethylene, methylene chloride. And we call these older generation solvents because not only have they been around for a long time, but they all fall into one category that we feel isn't sustainable, and that is on the social level. They're all rather nasty for your operators. As you can see, the ppm limits are extremely low compared to what it would normally be for a sustainable process. On the right, these 0.004, 0.05, really anything under 10 is unsustainable in a manufacturing environment. It doesn't matter how new your degreaser is, how tightly sealed it is, how good your process is. You're going to get, around 10 ppms over a time-weighted average pretty easily. So you might ask, why are these exposure limits so low? And why is that such a big deal? Well, because all of these solvents have usually been involved in some type of either litigation or major expose that has gone on to show the serious health side effects that they've caused to operators using them every day. The 2 most famous examples are TCE getting into the groundwater outside of Boston, Massachusetts, and causing cancer, increased rates of cancer for children in that area, and also the MPB glues used in the furniture industry in the North Carolina area, where all of the operators that have been gluing down the furniture came up with a list of serious health side effects. So it's time to move away from these different solvent options because they're not sustainable for your operators. So what have people moved to from these? Most people have moved to trans blends, right? And so trans blends, the main component is trans dichloroethylene or TDCE. And TDCE is a great cleaning solvent, and it's not terrible for you. The exposure limit isn't great, but it's still pretty good. The problem with TDCE or trans is that it's flammable by itself. So you can't have just trans in your vapor degreaser. It's got to be blended with some newer generation things that are considered fire retardants. These are solvents like the Novec 7100 or the Vertrel XF. And so you generally have 60 to 70% trans and 40 to 30% of these fire retardant solvents. Now, for those of us not initiated in chemistry or having a chemical degree, this can be a mouthful of how to pronounce these different solvents. But I bring them up for a very specific reason. As you look at here and you can see nonafluoro isobutyl ether. The nonafluoro means 9 fluorines, decafluoro, 10 fluorines. Same thing down here, 9 fluorines. You can see all of the Fs that stand for fluorines on both of these chemical structures. That's really important because the EPA is taking a really hard look at all of these fluorinated compounds that have large numbers of fluorines in them. The Vertrel XF has been identified as a global warming solvent, and that's this second one here. It has a global warming potential of 1,300, so it's been put on a hit list. These other two compounds, which are ethers, they've been considered polyfluoroalkyl substances by the EPA. And so what is a polyfluoroalkyl substance or a PFAS? Well, I'll go over it briefly here, but if you'd like to learn more, our first part in this 6-part series has been entirely on what is a PFAS. So please go and check that out if you haven't already watched it. But the EPA identifies PFAS as a group of manufactured chemicals that have been around for a while, but mainly because of their useful properties, right? The EPA admits they have really good things such as flame retardants, Teflon has a variety of uses. The problem with them is that they're considered forever chemicals, right? And so they're staying in the environment for an unreasonably long amount of time. They're not breaking down like other compounds. And when they don't break down, they eventually get into the groundwater, human bloodstreams, other places they're not supposed to be, whether or not you're accidentally or intentionally dumping them. And the reason is because they just don't break down. You know, they're going to get different places eventually. The EPA particularly went after 3M when talking about these different types of PFAS molecules, and 3M responded by saying that they're going to exit PFAS manufacturing by the end of 2025, which is just right around the corner. And so if we go back one slide very quickly, these two ether molecules, both manufactured by 3M, they're both going away. And this is why we feel trans or trans blends are no longer, or at least not currently, a sustainable option, because all of those fire retardants are going to go away sooner rather than later. And now you're left with an extremely flammable solvent that's no longer safe. Where do you go? Well, our suggestion is to go to HFO technology, and that's the latest in this kind of chain of different halogenated solvents that have come out. So what does HFO stand for? It stands for hydrofluoroolefin. So what is an olefin? An olefin or an alkene is a compound that contains a carbon-carbon double bond. And I say that with emphasis because that is why these compounds are better. This carbon-carbon double bond is more reactive than these carbon-carbon single bonds. They're what allows it to break down. They're also what allows it to form polymers. And that's probably where you've seen olefins already, both in synthetic fabrics, and polypropylene and polyethylene are both olefins. So we're using that same tried and true technology in order to create a better vapor degreasing solvent. So what are the benefits of using an HFO? Well, the biggest two are that it's already been tested and proved by a couple of big agencies. It's used to clean liquid oxygen components and do liquid oxygen verification cleanliness testing at NASA, and it's used to clean the Navy pilot O2 mask by the US Navy. So when we talk about our societal sustainability things, our two big things where we needed to make sure that your solvent was non-flammable, we needed to make sure it was safe for your operators. So NASA really tackled the flammability aspect. They did extensive testing at Marshall Space Flight Center in Alabama, the Stennis Space Center in Mississippi, and the White Sands facility in New Mexico. And they certified that the Solstice is safe for liquid oxygen environments on their standard 8070-0001. And this is really important because that's about as good of a flammability rating as you can get, considering just how sensitive liquid oxygen environments are to flammability. Anything that sparks is going to make a whole big tank go boom. Secondly, the Navy, for its naval aviators, has certified that this is a safe solvent. They've actually cleaned out their breathable oxygen systems and certified it to mil-spec 1330 for that type of cleaning. That's really important because any possible residue in these breathable oxygen masks that the aviators use when they go up is going to be not just to get into you, it's going to be directly inhaled because that's your breathing apparatus. So they had to do extensive cytotoxicity and health studies in order to make sure that it was safe for the pilots, because we know that a little bit is probably getting in there if there's any residue. So we've certified from the US Navy and NASA that this is a safe and non-flammable option for your operators. So let's talk about the HFOs versus the transblends. So the main reason the transblends are under attack is this global warming potential or the environmental aspect. So Honeywell has led the charge in this HFO technology, and they've already talked with the EPA on making the solvent VOC exempt. They've ensured that it's not a hazardous air pollutant, and it has a global warming potential of 1 compared to the 1,300 of one of those fire retardant chemicals. Now, probably most importantly is its atmospheric life is only 27 days. And that's the key because that's what, again, we're talking about that carbon-carbon double bond here that allows it to break down quickly. So as you can see, it's a small molecule and it does have 3 fluorines on it, but that's 3, not 8, 9, 10, or 11. And most importantly, these PFAS molecules that are coming under scrutiny because they're forever chemicals. They're hanging around for a long time. They don't break down. That's not the case with an HFO. It breaks down fairly quickly in the environment so that it's not staying around. And then additionally, it has a personnel exposure limit of 800 ppm, which is well above those 10 to 100s that we were seeing earlier in the older generation solvents. And that just goes as another data point to what the Navy was talking about with certifying it for breathable oxygen systems. So what do you need to know when you're using an HFO, right? HFOs are cost effective when used properly. That's the third part of our sustainability equation, right? The prices are similar to transblends currently. However, we are very confident that the transblends are going to go up in price. And that's because those flame retardants are starting to go away. 3M has already said they're not going to manufacture any more of the 2 most popular flame retardants. Therefore, the supply is going to dwindle and the price is going to go up. Not so with the HFO technology. From an operational standpoint, you got to be aware that it has a lower boiling point than the traditional solvents. Generally, it's a little bit below 100 degrees. The trans blends tend to be just above 100 degrees, and the old generation solvents are even higher than that. The only time this is going to be a major issue is if you have a chilled water refrigeration system. So the older generation solvents were able to be condensed with chilled water. That's not going to be the case with your HFO. You need a dedicated refrigerant system in order to condense it. Now, that's not too big of a deal for most people because the trans blends also run on dedicated refrigerant systems. So if most people are already running the trans blends, most people already have refrigerant cooled machines. The other thing is that it's a neat solvent, which is a really big advantage. You have a single molecule, you don't have anything blended in, no stabilizers if it's going to go acidic, because it's not, no flame retardants to keep it from catching on fire, because NASA's already certified that it's non-flammable. So that neat solvent makes things easier to sustain on a day-to-day process level in the long run. The last thing is, because it's a neat solvent, it's easily distillable. So you don't have an azeotrope that you have to worry about. With the trans blends, a good chemical supplier will give you a good formulation that will be stable over the long run, but then it's on them to make sure that that's the right azeotrope. Uh, if you're using a cheaper trans blend, there's a chance that that can get out of whack, and you don't have to worry about whether or not you're using the right trans blend when there's no blending. One molecule, it distills, gets the oil out of your system, and clean solvent back in. So all in all, that's why we feel HFOs are the most sustainable option, both on an environmental, social, and economic aspect. So I've polled some of my people internally to see if there are any kind of questions that they have about this topic, and there were a few that came up. So I'll go ahead and answer those now, because I suspect that many people have similar ones. So are there non-halogenated solvents that are sustainable alternatives? Uh, the answer to that is yes. It's a little complicated because there are not good alternatives in traditional vapor degreasing. That's why we are so confident on the HFO option. If you want a truly non-halogenated solvent, that means no chlorine, no bromine, no iodine, and no fluorine, you're going to have to go to a vacuum vapor degreasing option. So the vacuum systems are really nice. We think they're also sustainable, but they require a little bit more investment up front on the equipment. There's a good tech to tech as well on vacuum degreasing, so please check that out if you're interested. Can you switch to an aqueous process? Again, the short answer is yes, absolutely. The two biggest things to look out for are metal compatibility and drying. Solvents tend to have better metal compatibility than aqueous processes, and they dry much faster. So you have to balance those two things with what are your particular needs. And then, are there other trans blends that are sustainable? The hard question, short answer is not yet. There's a lot of R&D going on in this space to find some replacements for those flame retardants. We're doing a lot of other people are. There's some rumblings that there might be something out there, but nothing has been proven yet. So that is all I have for today. Thank you all very much for your time and attention, and I will turn it back over to Sherry.
Thank you, Jason, and thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KaiZen regional manager or send an email to tech@kaizen.com, and we'll have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.